just going to start. Uh, Hi, everyone. Welcome to GTG Surrey ML Paper Reading Club, session number 3. Um, we already have recordings from previous sessions on the respective event pages. Please go ahead and check them out if you missed any. Join our Discord channel. You'll find the link on our landing page, that is GTG Surrey. With this, I would like to invite everybody to collaborate on the GitHub repo that we created for this particular club. If you have any initiatives for us, let us know. You can always send them an email, or you can message me. You can message Elka, and she'll let us know. Um, let's connect. Let's learn. This is to collaborate and learn together. And I hope we all achieve something. And I'll send it over to Elka and Sergey now.
Thank you, Preeti. So, just continuing and building upon what Preeti just said. Hi, everyone. Welcome to third version of our ML Paper Club. And today I'm really excited that we would deep dive further in semantic enhanced programmable knowledge graph. And before we just basically, when go ahead and jump in, Sergey would take over. Let's quickly review what we did in the last session. So we covered chapter 1 and chapter 2 in the last session. We talked about knowledge graphs and why exactly dynamic knowledge graphs are important. Uh, Before we had static knowledge graphs and we had binary models, but nowadays, and so when English came in and when we thought that we will make computers understand English, we came ahead with a few frameworks called RDFs, OWLs, and this white paper builds upon those frameworks, and basically it adds a context based understanding, a semantic understanding to the edges. While LPGs, we talked about LPGs, they were great for structure and defining the language. Now when we use this framework, we add semantic reasoning to it, and we would build upon how exactly the SPGs work. So today we would be actually diving in the nitty-gritties of the work behind the scenes of SPGs. We would be looking like how it works under the framework, what is the schema, engine, what are the controller layers around it. And what's super interesting is that how SPG is just not about storing the data. It's programmable, it brings deep semantics into the mix, and it's designed to work smoothly with big data systems and whatever we have in the AI technology these days. So it can be a data warehouse, it can be a database system, vector databases, and everything. So this is actually really important when you think about it, because it tells us how it could complement a LLM, like any GPT model, and it can tell us that how you can tackle things like factual errors or reasoning mistakes. So let's get into it. That's enough from me, and can't wait to hear what Sergey has for us today. Sergey, would
Okay,
you
thank you.
like to share your screen, or would you like me to share your screen?
Can you share the screen because I have some issues with this tool? Yeah, but can you share the screen? Can you open this document that I made a pull request on GitHub,
Sure.
chapter 3 to 6?
Sure. Okay, Preeti, can you download it while I log in? Uh, I don't know why it's logged out.
Okay, I
Right.
will make a. Okay, I'll try to open in a new link. Sorry for this disruption.
Mhm. DOTP. Okay, perfect. I'm in.
Okay. It simply doesn't work.
No worries. I'm trying to basically go to GTG Surrey's page, and I would fish it out.
Can you download from the GitHub? No, or I can give you the straight link.
That would be perfect if you have that.
Okay.
But I'm in
Can I
annotated
upload
ML.
here? Can I upload here the documents? No.
Yeah, please.
Okay.
I don't see the pull requests, Preeti. Oh, I do see it.
Okay, we'll open this. You know, I opened on my own laptop, but I cannot share the external window, so it doesn't allow me to do that.
No, I understand. What is your, do you have the commit ID with you? I can see two
Yeah.
pull requests.
Yes.
One is chapter 3 to 6. Is that the one?
Yeah. This is right.
And your GitHub ID is L3R?
Yeah. That's my ID.
Got it. Okay, from here, I basically cannot download your file.
Okay, let's do something another. Okay, I will make a.
It just tells me that, yeah, it keeps opening the same. And it tells me that's some binary file, view file, no, the same thing. Download.
Give me
I got it. I'm there. I'll share my screen quickly.
Okay. Yeah, this is it. Okay.
Oopsies. Just a second. Yeah, I'll share it again. Yeah.
Yeah, this is the start of this third chapter. So, as you mentioned, that we discussed and annotated the lack of, ontologies as it was described in chapter 2, and a lot of approaches. I mean, the common approaches for building the rack, that they don't have a time component and event component, or if it has a like a textual representation, it could have a different meaning, because LLMs could represent the same event or the same entity in two different ways, because he can lose a context and it could lose the meaning of the entity. So basically, it could have two entities described in two different ways. So the SPG approach allows to combine that and formalize that in a hierarchical way, like to use RDF or ontologies and build more productive and more accurate augmentation generation, and they call it knowledge, based on knowledge. So chapter 3 is like focused more on programmable framework, and this is like describe the presentation of that framework. So it focuses on semantic enhancement of this programmable framework, and this page so it's like basic introduction of this framework and overview of this, the purpose of defining and representing knowledge semantics. So it tells us about advantages and managing enterprise level business scenarios. So just showing like several examples, building this generation, the basic on formalized knowledge representation. So if you want, you can, there is a small tooltips on no, just scroll up. Yeah, this one, the yellow one. Yeah, this one. Yeah. So it shows us hierarchy and dependencies between properties and relations. Yeah, during modeling and reasoning. So so it's like basic summarization of this page. We can move further. So to the next page.
Do you want me to?
Yeah. Can you make zoom out? Yeah, like two. Yeah.
Tell me when to stop.
Yeah, it's okay. Yeah, it's okay. So this like this option, this text represent the semantic model of SPG. So the semantic model of SPG is like explaining the formal dimensions, like domain type and structure constraints, and as well as unique instance with the domain. So it's like logical dependency between knowledge. So it focuses that it's important to have such dependency. The whole framework is like, it's like showing us that it's importance of that connection between data and how the data transforms. Like so, it's important to formalize the connection, and like the example that would be shown later shows like how to connect that and formalize it with the classes, ontologies, and the way, the representation in code. And this is like plan of attack that they will describe that later. Yeah. And also they show us that importance of unique instance within the domain, because some of LLMs, some of approaches could last the focus on the domain specific data. So yeah, emphasize that SPG requires that every instance within a domain time must be unique to guarantee the accuracy and consistency. And they have a specific tool that allows us to grab the data, parse the data, and formalize the unique hierarchy, and formalize it as a unique entity, and to build this entity structure and connect these entities between them. Yeah, we can move further to the page. Yeah, this is what I meant, logical dependency between knowledge. So this is connection between such entities, and it could be formalized between, not only between entities and between knowledge and thought, and it's make it more accurate reasoning and inference also. Yeah. Because it involves all the data type with their properties and structures. Because it's better holding association and dependency between knowledge. This also emphasizes, this chapter also just gives basic representations that it could also do that like semi-automatically, because it works in the pair with LLM. So basically it could handle the process of creating ontologies, but user could modify it and edit this ontologies and produce more accurate data for this augmentation generation. Later, they will describe that process. Can you move further? Yeah, this SPG framework efficiently bridged the gap between big data architecture and the knowledge system. So it's like a common motto for them. So they emphasize on big data, and it's like a huge gap between the LLMs and big data, because the big data could be unstructured or semi-structured. So they trying to organize such structure and connect that data with the LLM for reasoning and for better system understanding or understanding of the system. Sorry. Yeah, we can move further.
So, like, I think this is it for chapter 3, or do we have anything else? Oh, right. Okay. So, do we go ahead and basically discuss this architecture a little bit, keeping the diagram in point of view, because that
Yeah, this is a
basically
basic set of tools like SPG programming, and this is a layer that allows us like Python or Java SDK. It's written only Python. I think they have a Java SDK as well. That allows us to. I'm not sure, but I think they mentioned that later. But they mostly focused on Python because Python is like a common tool. yeah, for all the libraries. But some of the tools firstly was written on Java, so then ported on Python. So SPG programming layer is like the way how to write the ontology. So it's simply like writing new classes and functions that use function as a method of the classes, and provide the common interface for guys for coders, who can organize the structure. Yes, SPG LLM is like user interaction based on LLMs. Like you can simply ask to organize that structure and post that data into that core components that they will transform the data into well-organized structures like OL and RDF. So also they have an examples later. So we wouldn't focus on a code, but yeah, they have a lot of examples. I think I will briefly give some comments, but not on, we wouldn't stop on each code. So we can move further, and yeah, this is a few concepts that SPG control is like reasonable for design of the control center system. So it's like responsible. Yeah, it's like common distribution and organizing code execution. It's like task planner. It's a main one of the main core components. as I mentioned before, SPG programming layer is like programmable framework, subsystem responsible for a design, SDK that is responsible for knowledge constructor and knowledge evolution, and SPG engines like knowledge graph engine subsystem that is responsible to design and integration adaptation layer for multiple engines. So it's like simple orchestration and query engine. So it could has a queries, like you can ask queries on this engine, so it simply can you know, apply requests, user requests for themselves. It's hard to realize, but you can ask on the data which data you use to model the new data. It's like recursion in normal programming. Yeah, the objective. So we can move further. An objective of SPG. Yeah, you can scroll down.
I have just one question over here. So I understand that the engine that you just talked about, it's more of a, it's the brain of SPG, and that is the integration layer. And basically, that is the point where something, a query engine or something SQL like a paradigm or our interface through which we can basically query the data is there. But I don't understand, like, how is it a recursion?
Recursion is like you can ask to build some model, to build some data, and you can also represent it as a event to build me the model, or to build me the data, and you can later call that like a function, like method, and to build a new event and new function that will call the function that we built first. Like it's like self-execution function that will like do that in a repeated way.
So it's very close to inferencing, right? And it gives the control to user.
It is inferencing, but based on on programming format structure.
Okay.
You can also form the inference, like for example, give me the address and email of such person, and form that into event that you are like asking this address and the data of like other fields of context. You can not only have this in a text representation like prompt, but you can code it into actions, and this action like parsing would be like parsing the data of a user. So it will be shown later, I think. But I saw that on KEG, the realization of this framework. So they built a framework that allows us to have it's like solution that use that framework to get the data and to build knowledge base for your needs. Okay, we can move further. So about SPG framework foundation, semantic foundation framework. Yeah, this is semantic foundation. So the framework schema models SPG through two business cases. So there are two business cases represented. Like first is SPG logical rule framework. It includes the logical rule system. This is SPG rules that will be described later, and they they runs from the SPG to LPG solution. Yeah, this is like a tool, and There is a second case like SPG multi-engine adaptation layer. It provides detailed introduction and it corresponds to graph storage and graph computing. So it's more like building more effective graph. So we can move forward. The page, the fourth chapter.
So I would,
So
before we, I'm sorry to stop you, Sergey. Before we move ahead to chapter 4, I would invite someone, either Carol or Yashpal, if you have, any questions on chapter 3, or basically if you want me to summarize it, anything, please, the floor is yours. I'll wait for 15 seconds. And a water break. Okay.
okay.
Going once, twice. Okay, so no questions as of now. So I think what we understood in chapter 3 is it basically does nothing but introduces the framework. And when I say framework, what does that mean? Is that SPG, well, it's just not connected data points, as we saw in the previous ML paper club, that it basically introduces context to domain specific rules, right? And it makes sure that everything is consistent and it avoids duplicates. And like you can take an example that if you write NYC, earlier it held no meaning now, but if you write NYC now, it basically knows, because we use LLMs, so it basically knows that it's New York City, and it knows that NYC and New York City are the same place, and though that's the context they have added in the relationship. Plus it helps all the frameworks and all the machines to not just store the facts, but it actually reasons with the rules. And that's how it basically, that's the coolest part. But I think also that it bridges the enterprise data with AI models. So every open source project out there we see is based on open source examples, but enterprise data is not open source, and those are the data which are structured, but they lack this LLM component, and that's how this particular framework is beneficial, because it focuses specifically on the enterprise data. It extracts valuable insights from there, and it improves the accuracy as well. So instead of using this framework, instead of AI models making random guesses, SPG helps them think more logically and efficiently. So uh, SPGs are nothing but it basically makes your knowledge graphs smarter, flexible, and it ready to use for enterprise data. So I mean that wraps up chapter 3, and we can go to chapter 4, SPG schema layer, where we would be looking at the architecture of SPG. Over to you, Sergey.
Yeah. Can you show me just a page number, because I
Oh,
missed it. Yes,
35.
it's 34. Okay. Um, okay, the FPG schema layer. So it's overall architecture. This SPG schema. It's like describe the integration of SPG subject and classification and extraction of semantic predicate logic. So basically, give us uh, some vision of how it works, and the ways how to organize the data. Uh, Simply is mapping like columns, fields, and tables models of types, properties, and relations uh, inside the SPG subject model. So it's, as I mentioned before, it's an organized structure, and only this approach provide more accurate data for reasoning and for inference and modeling also. So we can move further. With it, yeah. This is basic representation of like basic bricks of such mechanisms, like what is entity, that is event, and what is concept. So the SPG programming layer, it manipulates such bricks, and organize the data structure and describe the events. The list of the basic types of SPG. So it's like entity, concept, event, what is property, what is relation, and describe the entity types and how they relate to each other. So simply it is like describe the world and make this events and entities, that how they organize between, and like described it in a digital world. So it's like simply of understanding. So basically it's like classes, for programmers, it's like a set of classes and a subset of or subclass of the entities. So that's well organized, and we have like method and textual representation, connection between basic entity and types. So it could be organized in the subset of subclasses of classes, and could be linked with concept with basic entity types. We can move further. This is
just to simplify it for all of us, Sergey. If I go up, then basically entity is nothing but your objects, and relation is nothing but how you associate those objects. So the nodes or the vertices of my graph are nothing but entity, and my edges would be the concepts. Am I right in thinking that?
entities nodes, and relation it's
Edges.
edges.
Yeah.
Exactly.
So that simplifies, I think. So in
it's
all
not
of
all, because there have like more basic types, like properties, and event, because this component, the type component, they describe it like as a event, the entity that changed, entity that changed the impact of event.
yeah. Okay, so event can be a connected object of an entity, or is it a property of entity?
It's a property. It's a property that changed the property, like
Oh,
the
it's an
property.
action. So I
Action.
think
This is this action. This
got
is
it.
action.
So your nodes are entities. Your nodes are entities. Vertices are concepts. Now, event is an action which can change the property of an entity, right?
Yeah.
Oh, perfect.
So describe the entity types, so how would they differ from each other. So can you click on the balloon, this yellow, this one. So the changes in the knowledge, the graph construction. So the primary ideas of structures is SPG schema layer, like we can have this schema. Sorry. So we have a abstract instance and abstract event. This is like abstract layer, and then we have a concrete layer. So you can scroll further, and will be like separation between the abstract and concrete layer. In this chapter, subchapter, they describe the trade-off between RDF and LPG. So LPG is like simply not enough with data representation, and efficiently reduce the data preparation cost. So with with such trade-off, and SPG schemas introduce standard property types, yeah, to simplify data properties. Can you click on this yellow balloon? Yeah, so reducing the data preparation costs by simplifying dependencies between RDF and LPG models. So simply, there is a mechanism that converts in a repeated way data from SPG to LPG to make it more to give additional layer of representation. So and this mechanism described as such process. Yeah,
Nice.
we can move further.
Okay, so let's talk about the syntax layer and all the. So, do you want to basically talk with the diagram, or would you like me to go?
Just simple because it's like it will be well described later. But the syntax layer is like content of SPG. Like this is a main structure that's written in a programmable way, and they have the bricks that we seen before, like entity, section, and like programming interface allows us to organize the data and describe the events with these bricks, and this form the schema, and yeah, this is a syntax layer. Okay,
Maybe
we can
the
further.
rule-based layer, basically. So there are two layers, as I have understood in SPG schema. So one is the rule-based layer, which is the syntax layer, and the one is context-based layer, which is semantic layer.
Yeah,
So
you can move. Yeah, just little down. Yeah, this is an instance. This is a model, and this is a. So the graph, the like the whole structure of the data, like graph data, the main specific graph data, and the structure syntax of SPG. So and elements and rules for modeling of such concepts. It's so it's more like scheme of model hierarchy in the describing for layers, and there where layers will be described later. Yeah, just little. You can scroll down, just little down. Yeah.
Okay, let me
I
just.
think it's repeated like yeah. It's like syntax semantic layers SPGs. So explaining the classification of semantic constraints, effective reasoning. Yeah, it gives us better ability of better reasoning of the data. When you ask some data, in text representation, it could reason more, so in more accurate way.
Yeah. So moving ahead. So
This
do you want to do all the layers individually, or I think it's pretty self-explanatory, right? Because it's basically the things which we saw here, meta model, the SPG meta model, and the instance. I think meta model is the base layer where you define all the entities, and then on top of that, when you start defining the relationship on that, that basically becomes your SPG meta model. And when you add domain knowledge on that, that becomes your model. And the moment you start instantiating it, that becomes the instance model, right?
Yeah, it formed the whole instance. Yeah, the whole instance structure.
So I think we can move to semantic enhancement of nodes. This is the part where I'm most interested in, because I'm interested in understanding how basically did they add context to the relationships. So
it explained how each architecture layer contributes to the SPG frameworks, and emphasize the flow from abstract modeling to instance level data. So the key points of such description is definition and roles of meta model, SPG meta model, and instance layers. So you can move further to page 41. So it will be like describe the syntax and semantics for node type. So it's like basic creation an entity, yeah, with the SPG taxonomy property, yeah,
Oh,
it's like
yeah.
a
It's
definition.
very much like how you define a table, right? How do you define a
Yeah,
table?
very common, but specific more for graph databases. So it's
Mm, of
like
course.
mixture of graph databases queries and ontologies. So it's very like not so specific, but we can describe basic. Yeah, there is a specific PGKs, like exclusive, mandatory, singleton are used to represent unique, at least the most constraints, respectively. So the framework emphasizes that one conceptual unique entity in the world should be represented only as a one entity in a knowledge base. It's the main idea of that framework because it allows us to reason better because it wouldn't lose focus and attention, lose that facts that have a connection within a graph. For example, you have your favorite car, but what was your favorite car in the movies? In that particular movie, yeah, based on that context that you described, or your favorite car in your life, or maybe this is a favorite car from some cartoon, the name
Yeah.
of a character, do you remember the children cartoon that the cars, the racing cars?
Yes.
Yeah, maybe your favorite character, and so the basic and context, it should organize that structures and their ontologies, and this is the way how to not to add new entities in a knowledge base. If you have, if you want to describe the same entity, from the real world. Okay,
So
let's
I
move
can
further.
visualize
Page.
it. Yeah. So I was
Yeah, just
thinking that I can visualize it like I'm a person, I'm a node. I have an interest favorite car, that's an edge. Now this
Mhm.
favorite car, as you said, is can be anywhere, right? In my life, in a cartoon,
Yeah,
in anime.
it is the same entity. It should be represented as a new entity. It shouldn't be. So it have to be represented as a same entity. And if you want to organize some new, like description properties or events that connects with that entity, you have to link that entity and describe that like linked events, linked properties to not to create do not create the new entity because it lost focus to the main concepts and main properties. So this is the main reason how to organize all the data in the well-organized structure. I mean, we have unique entities and we have connections. We have that represented in a graph.
Oh, okay.
Okay, we can move further because it's like basic, creating events, how to create event, how to create,
Yeah.
yeah. This is your question, what is the H type?
Yeah.
Uh, yeah,
It's really similar to how you write RDFs and OWLs. So that's what they have been telling that on the OWLs they have added semantic, and that's where my interest is. That how basically would you take a relation? It can be a binary relation or you can be a many to many relationship, and then how do you add context to it? So that would be interesting to see.
yeah, this is the main rule, like they're trying to, follow. Like binary constraints should be defined irreflexive, intransitive, and cyclic, and anti-symmetric. So it's like it's very similar to like do not repeat yourself and kiss and dry approaches in normal programming. So these concepts focus more on the properties of binary relation and are usually defined together when defining the relation. So we can see that the more simple ways, and then we can move to the more complex way. We wouldn't stop on the creation, but we can see that the basic creation, like edges, classes, properties, and how to relate to the classes.
So they have like 4 to 5 types of relationships: reflexive, transitive, cyclic, and symmetric. Okay. And what is a reflexive relationship? Have they told about this? Oh, yeah.
Yeah.
It does it on a OWL format. If you know set theory, then you can read it. T includes a set which is where the
Can you
number.
make it just little more, because it's just little zoom out. Then after the zoom out. So it's from menu to. So it has a model. So it just give us a representation. Is it true or false? Like 1 or 0. I think.
Okay.
It's like has a class or not, doesn't has a class, or connect to the class or not, or has a property or not. So it's like Boolean binary representation. Descending multiple binary relation. Okay, let's keep that because it's like emphasizes on how to create. This is relation grouping, so we can group these relations in some named group and construct more effective, like groups that organize several predicates, and to reduce the cost of computation. Relation groups. We can move just little for further. We can also group the properties. Dynamic types. So different domain types may be different hypernyms to express hierarchical relations. So we can define the events that has a hierarchical classification of the events in different conceptual domains. So this is important because we can have one document that cover 2 different domains. For example, medicine and technology, like X-ray. And basically on the entity, we need to focus, to change the focus on as well as context. So it's important and to give us the way how to organize such and manipulate such domain and how these structures relate to each domain.
So as I understand, hypernym is nothing but a common noun. Basically, if there are multiple domains, let's say there is a domain called animal, then animal is a hypernym. And if I want to have an animal of specific type, for example, an owl, then that owl is a okay, no, that's a proper noun. But if I say that, it's a bird, then it's a hypernym. Is that what it's talking about?
This is hypernym.
Okay.
Yeah, they're talking about and how to change then you can use that concept to change the domain, not to change, to organize the domain cross inference between domains. So you can change the focus between the domains. It allows us,
Understood.
Okay, you can move further. They belong to predicate. Associating this. Let's talk about associating a concept instance with the entity instance or a event instance. So basically, we can have a concept instance, and it can be associated with the event or some basic bricks that I mentioned before. Subject and predicate. This is semantic enhancement for rule definition. So we can define the specific rule. so not only like a syntax, we can define programmatically. Sorry. We can expand the H type syntax using the rule keyword. So there is an example. They define. It's very common, like syntax to defining the rule. There is a code example, and to make more specific definition for the classes and the instances of classes. Sorry. So it's more, can relate to organize the structures programmatically. Yeah, to have a set of rules, we can group the rules, group the set of rules. We can divide it into some specific condition. So it's very flexible, and you can organize the data, like in for your specific domain. Okay.
Yeah, so this is really, as far as I have been understanding this, there are different types of rules you can define, and pretty self-explanatory. I mean, the moment you say it's contradictory rule, then it's basically, is A a contradiction, or is A the opposite of B? So pretty self-explanatory rules. That's really good thinking on their part. Because we are getting to the closing time, so I would say that let's skip chapter 5 for this time, and we can park it for the next session, and let's complete chapter 4 as of now. What do you say, Sergey?
Okay, but this it's almost so I almost finished the chapter 4. So there is only this is the right page, the relation between the schemas and PG schemas. So basically, this mechanism provides us an iterative way how to convert the PG schemas to SPG schemas. So SPG allow us to organize with the code these structures, the data, and with node types and operators like AND and OR, we can provide rich type expression capabilities. So it's like more programming way how to organize and manipulate the data.
Okay.
So it's more specific, on coding. There is several code examples, and they mentioned in the refer. They have a reference to that code example. So there are several. You can just scroll just a little down, and here they mentioned about the complexity of validation maintenance in specific query languages. So it's hard to organize the data, especially if the data is evolved. So SPJ allows us to control that the data evolution, and so how the data was changed. It also could be described in the as a classes and events, also described mentioned before. So binary these features are lacking in other works such as RDF, Shekel, and Shex is names of the approaches of its frameworks. Frameworks, RDFs. No, it's the concepts. It's the concepts of storing the data, RDFs, and they emphasize the lack of such approaches, and so it gives us basic understanding that PG schemas is primarily focused on enhancing database management, and with features such as improved type definition and strengthened key constraints. So yeah, we have seen that it could be well described with constraints, with events, and organizing such approaches. Yeah, we can have a good schema that could be well described the whole data structure. Okay, we can move further. The next page, page 53. Yeah. Yeah, this summarization of such this four chapter. It's like organize a form user-friendly and complete syntax and semantic system. So basically, they describe how to organize as this set of comments. Yeah, the syntax is describe the comments and this programmatically hierarchical interface to build such ontologies, data structures, and how to describe the data manipulation.
I understand. Okay. So interesting. I think chapter 3 and 4 were one of the most interesting chapters we have done, right? One and two
I
was
think yeah,
just
because they give us the code examples that you can really code if you try your own. But then they also describe like a sugar in that framework that some of the code syntax could be produced automatically. You can write a text and it allows you to convert your text into ontologies and into code. So it's more interesting way how to organize, how to write the code, how to organize the structured data. So this
yeah.
is like the main goal of such framework.
Understood. And this is actually how do I say it? A nice initiative that you are basically taking it on the domain data, so or enterprise data, I would say domain specific data, and chapter 4, I thought that it just basically told you how to define rules, how to define entities, relationships, and what are the different types. It's basically just setting uh, more like a documentation of syntax.
Yeah,
So
exactly. Yeah,
yeah,
because they call the schema. Yeah, this is a real focused on the syntax.
yeah. So I think we would get to know more about the engine and get to more about the LLM part of it in coming chapters, chapter 5, chapter 6, which I think we
Mhm.
can cover in the next, uh, in next basically meetings or GDG series events,
Okay.
right? I think we are way ahead of time, and we should be, I would say, wrapping up. I thank you so much, Sergey, for taking up chapter 3 and chapter 4. We today saw all about the semantics in SPG schema layer. What are the different types of rules? What are the different types of entities? In chapter 3, we saw how SPG adds the semantics or the deeper meanings. Basically, we saw that there can be hierarchies between the entities, that and how there are different types of relationships. There can be a contradiction relationship, there can be a transitive relationship. It's basically, if you see, then it's very much based on the standard 5, standard 6 sunset theory which we read. And overall,
Mhm.
I think SPG, I'm getting continuously impressed by SPG. I think SPG transforms the knowledge graphs into from static to dynamic. We have LLMs everywhere, and we don't have a lot of LLMs in knowledge graph section. And this is a good initiative. We are building intelligent systems which will better support AI applications in enterprise systems. And I am actually excited to hear what your thoughts are, how it will be more evolving in the coming years, and we can discuss that.
Yeah, I hope so that this framework will improve, because they mentioned later in the next chapter, they mentioned that about evolution, that's a framework. So now they have a like straightforward way how they organize the data from text description to the structures, but they mentioned that on a way how the structure could form the new text representation, and like we can have a augmentation generation when the human in the loop, the common structured approach to to organize this digital world. So
Hmm.
Yeah. So I think this very promising engine, and w- we can use it in our own solutions. It's have some limitation of license, yeah, but some of them is well described, and you can build your own solution based on the some some approaches. You can use like an idea, and yeah, some of them like free use, like for non commercial purpose. Yeah. So yeah, but in general, it's very interesting framework, and I hope so. We'll study it more, and I can use it more, and yeah, we'll move further.
Yeah, it definitely is interesting framework, and there was one place where you are completely right. When you have to work with enterprise data, there is a lot which gets blocked by licenses, and I hope if these sort of, not exactly this framework, but this sort of framework is being adopted worldwide, then probably we will have better knowledge graphs in the system, in the enterprise system on production level in coming days. And that wraps up. Thank you everyone for joining GDG Surrey's third session of ML Paper Club. Uh, the thing is that we thrive on participation, as we have mentioned. If you found this interesting, and as Carol said, you can go through chapter 1 to 4, and in coming session we'll discuss chapter 5. If you're interested in annotating the same thing as Sergey did, you can annotate your own paper and submit a pull request to GDG Studies GitHub repo. Um, I can paste the GitHub repo's URL over here, where you can basically go ahead and make a pull request after annotating. And the best annotated paper base goes ahead and wins it. We review all the pull requests, and if you basically win this, you can go ahead and present your paper as Sergey did. Having said that, if you have any closing thoughts, Yashpal and Carol, you are welcome to say it on the platform. Otherwise, we are, I think, good to drop. Going once, twice, thrice. Yes, Yashpal. All the previous sessions are on GDG Surrey's YouTube channel. Let me paste that for you. Okay, don't start playing something here. Yeah, so there's a playlist, and here is the playlist. Yeah, that's what I thought. It will start playing things. There you go. This is the playlist of our previous sessions. So we this is our second paper and third session. The first session we covered RAG, the retrieval part of RAG. The second and third session we have covered the SPG white paper. Also, if you have any suggestions on what should we be covering next, you can also put that as well here. You can ping me anytime on LinkedIn. You can ping Preeti anytime on LinkedIn with your suggestions, or you can send an email to any of us, and we would definitely take your suggestions in for the next papers. We also Preeti also keeps posting the say a poll on LinkedIn, where we go ahead and check, we like submit our responses to the poll. This time the in the poll the SPG paper won. So if you have any suggestions, or if you want to choose from the poll, you're welcome to do that. Sure, Rashpal. You're welcome to mime. I love mimes if they're not scary. So thank you everyone, and have a nice Sunday ahead. Thank you, Sergey.
Thank you, thank you, thank you, guys. Have a good day.